So you have Cl2 plus NaBr yields NaCl plus Br2. That looks to me like a single replacement. So I'm going to write that on here. Just because I want to be in that habit. So the first thing I want to do is I'm going to list out each one of my elements that are on the left-hand side. I have Cl, and I have Na, and I have Br. And then I want to list them in the same order on the other side. Just look across to make sure that I have actually balanced my reaction. All right, so the next thing I'm going to do is on the left side, I'm going to figure out how many of each element I've got. So there's 2 of those, 1 of those, 1 of those. On this, 1 of those, 1 of those, and 2 of those. So when I look across, I see that I have twice as many chlorines here as I do here. And for the bromine, I have twice as many bromines over here as I do here. So knowing my mathematical magic, I'm going to start with this one. So if I double this one, I now have equal numbers of bromine on each side, so I'm getting there. So now I've got to figure out how can I turn 1 sodium into 2? How do you double something? Multiply by 2. So I put a 2 here because the sodium is married to the chlorine. That doubles both of them. Okay, and I now look and I see that my chlorines are the same. My sodiums are the same. And my bromines are the same. So I have a happy equation. So I can put a smiley face here. Yay for smiley faces, right? Oh, come on, it's Monday. We just had a holiday. You guys haven't had school for 2 weeks. Come on. Yay, thank you. Thank you very much. I got 4 hours sleep last night, you know? All right. So this next one, H2 plus N2, so those are gases. And they yield a compound called NH3. So I'm going to say this is a synthesis. Ammonia. So again, same steps. List out the chemicals that you're given. List them in the same order on the other side. Notice how this subscript belongs to the hydrogen, not the nitrogen. So remember what I told you about 2s and 3s. Keep that in mind, okay? Okay, so probably the easiest thing to do would be to balance the hydrogens first. A lot of times they say leave hydrogen till last. But I know that if I multiply 2 times 3, I get 6, and that makes things a lot easier. So if I put a 3 here, and I put a 2 here, that pretty much takes care of it. So as you can see, my hydrogens are equal, and my nitrogens are equal. So that one balanced very pretty. I like this one, so I'm going to put a nice little smiley face there. I like the ones that don't give me too much trouble. All right, this next one doesn't look so bad either, so let's give it a whirl. I have two things coming together to make a new thing, so that looks like a synthesis reaction. Always, always, always follow the same steps in the same order, and it helps. So I have 1 sodium, 2 bromines, and over here I have 1 of each. So how do I turn 1 bromine into 2? Multiply it by 2. Now notice it's married to sodium, so that means that you're going to multiply the sodium also. If I put a 2 here, I have to distribute it. Okay. So now my bromines are happy, my sodium isn't. So again, how do I get 2 sodiums over here? How do you get 2 of anything? Times it by 2. So I have 2 sodiums, 2 bromines, 2 bromines, and another happy equation. Yay! That's right. Yay! All right. This one's a long reaction, so let's look at it. So I see copper, chlorine, hydrogen. This looks like a double replacement. Would you agree? Yes. Yeah. This is a double replacement. Okay. Again, follow those steps. I know it seems tedious. But I once had to teach myself how to do this, so. Okay, list them out. I keep them in the same order. Oops. Okay. All right, this one doesn't look so bad. This one looks vaguely familiar. Looks real familiar. Looks like the one that we did at the top of the page. So my coppers are happy, my chlorine and my hydrogen isn't. So what if I put a 2 here and I doubled that? Would that work? Yeah, it works. So instead of Bob Ross, I'm Mrs. Daniels. I don't do happy little trees. I do happy little smiling faces. Any of you know who Bob Ross is? Okay, good. Thank goodness. Because I make references to things sometimes, and students just look at me, and then I remember how old I am. So, I'm on my 5th decade. So. All right, HGO plus Cl2. This looks like a single replacement to me.
For our test on Monday, will we be able to have our periodic table out?
You won't need it, but yeah, you can have it. There's not really anything on there that'll help you. That's the downside of this one. Now, you can definitely have it for your final, so don't get rid of it. All right. My mercuries are happy. My oxygens aren't. My chlorines are not. Probably going to have to do some multiplying, because that's what I love to do. I love to multiply numbers in chemistry. Please tell me you don't believe that. Because I don't. All right. So I'm just going to start off, and it looks like probably the easiest thing would be to double that oxygen. Well, it happens to be married to mercury, so that means I'm doubling it too. Too bad it's not married to Freddie Mercury. He's dead. You guys don't know who he is, do you?
No.
Queen's lead singer.
I knew that. It was my dad.
All right, so I doubled my mercury here, so I better double it on this side too. Now my mercuries are happy, my oxygens are happy, my chlorines are happy. Funny looking happy face. We'll erase that because that looks terrible. All right. All right. We have carbon and we have hydrogen. Please don't talk. All right, so my carbons seem to be happy. So really and truly, all I need to do is to multiply my hydrogens by 2 on this side. And this looks like a synthesis reaction. And so that one balanced pretty nicely, I think. Was anybody able to get the combustion reaction? All right, I have a video to show you on combustion reactions. But first,